Mathematics is the study of numbers, the relationships between them, and the patterns they make. Some patterns can be unraveled by plotting the numbers on a number line. Plot some numbers on the number line as shown. Can you work out which number is equidistant from 2 and 6, which from 4 and 10? Observe that the number 4 is at the midpoint of the two numbers 2 and 6, while 7 is at the midpoint of the two numbers 4 and 10. Note that the middle number 4 can be obtained by adding the two numbers 2 and 6 and then dividing their sum by 2. The same is true for 4 and 10 as shown. Now look carefully at the sequences 2, 4, 6 and 4, 7, 10 obtained in this way. What might you conclude about sequences of this type? The three numbers in each sequence are in AP with common differences 2 and 3 respectively, and the middle numbers 4 and 7 are known as the arithmetic mean of the extreme numbers in each sequence. Hence, we can generalize that if A and B are any two numbers, then the number midway between A and B is equal to A plus B over 2. This number is known as the arithmetic mean of numbers A and B. Further, when the middle number is placed between the given numbers A and B, this forms a sequence in AP. Let's explore the arithmetic mean a little further. Given two numbers A and B, a number m can be inserted between them such that the sequence A, M, B is in AP. This number m is known as the arithmetic mean or AM of numbers A and B. Since the sequence AMB is an AP, so the common difference D is given by M minus A or B minus M. Therefore, we get that the arithmetic mean M equals A plus B over 2 as shown. Algebraically, we can also say an arithmetic mean is the average of two numbers. Geometrically, we can say that the arithmetic mean is in fact the midpoint of the line segment joining the 2 points that correspond to the two numbers. Let's understand the concept of the arithmetic mean by finding the arithmetic mean of 3 and 9. We know that the arithmetic mean m is equal to the average of two given numbers. Therefore, substitute 3 and 9 for A and B in equation 1 to get the arithmetic mean as 6 as shown. Now find the arithmetic mean of 5 and 29. We know that the arithmetic mean m is equal to the average of two given numbers. Therefore, substitute 5 and 29 for A and B in equation 1 to get the arithmetic mean equal to 17 as shown. We have seen that when we insert one number between two other numbers, we get a sequence in AP. Can we insert more numbers between any two numbers such that the resulting sequence is an AP? Let's find out. We know that the arithmetic mean m of any two numbers is given by the average of the two numbers. Let's consider two numbers 3 and 19. We get the arithmetic mean of 3 and 19 as equal to 11. As a result, we get the sequence 3, 11 and 19. Now consider 3 and 11 and find their arithmetic mean. By definition of the arithmetic mean, we get the AM of 3 and 11 as equal to 7 as shown. Note that we get the sequence of numbers 3, 7, 11, 19. Next, if we find the AM of 11 and 19, we get their arithmetic mean as equal to 15. As a result, we get a final sequence of numbers after inserting arithmetic means 7, 11 and 15 between two numbers 3 and 19 as shown. Now look at this sequence. Note that the obtained sequence is in an AP with a common difference of 4. Therefore, we can insert more than one number between two numbers such that the obtained sequence forms an AP. Now let's generalize our observations by stating that M1, M2 and so on up to Mn are n numbers inserted between two numbers A and B. The sequence of numbers obtained A, M1, M2, Mn, B is in AP. Note that this AP has n plus 2 terms as shown. Now we have A as the first term. Let D be the common difference of the AP. Then term B is equal to A plus n plus 1 whole D. As a result, D is given by equation 2. We know that M1 is equal to A plus D. From equation 2, we get the value of M1 with respect to A, B and N. The values of M2, M3 and so on up to Mn are obtained similarly as shown. These are the required numbers between A and B such that the sequence is in AP. Note that using this formula, we can find any of the numbers M1, M2, M3, etc. between the numbers A and B without generating an entire sequence. Insert 4 numbers between 3 and 23 such that the sequence is in AP. The key to solve the problem is to consider the first given number 3 as A and the last given number 23 as B. Then get the value of the common difference and, using the nth term of AP, find the 4 numbers to be inserted between 3 and 23. Let M1, M2, M3, M4 be the 4 numbers between 3 and 23 such that the resulting sequence is an AP with A equals 3, B equals 23 and N equals 4. Find the common difference using the formula D equals B minus A over N plus 1. Here D equals 4. Calculate M1, M2, M3, M4 using the formula by substituting 3 and 4 for A and D. Hence, the required 4 numbers are 7, 11, 15 and 19. Find the AM between x plus y the whole square and x minus y the whole square. The key to solve the problem is to use the fact that the arithmetic mean between two numbers is the average of two numbers. Let M1 be the arithmetic mean between x plus y the whole squared and x minus y the whole squared, with A is equal to x plus y the whole squared, B is equal to x minus y the whole squared. To find the arithmetic mean between the given two numbers, use the formula M1 equals A plus B over 2. Hence, the required arithmetic mean is x squared plus y squared. Do you remember that we have come across arithmetic mean in our statistics lessons? Now, is there any relation between the arithmetic mean used in arithmetic progression and that used in statistics? In fact, the two arithmetic means are the same. Let's look at this. Inserting an arithmetic mean between two numbers, say A and B, is actually producing an average of the two numbers. As a result, we have an arithmetic mean as equal to A plus B over 2. Moreover, this mean is equidistant from the two numbers. When evaluating the arithmetic mean of statistical data with n data points, we take the average of these n data points. As a result, we find that the arithmetic mean of n statistical data points is equal to the sum of n data points divided by n. Hence, it can be concluded that the arithmetic mean inserted between the two numbers is in fact the average of those two numbers. This calculation is extended for n data points in the case of a statistical data set.